I trust you, and I'm pretty sure that you will watch the video. If you have any questions and still don't understand, just you can send me a text to my phone, and that would be fine. Just make sure you put your name so I know it's from you. Anyway, I'm looking at your attempt. The first question you got right, so that's very good. I know that you know how to calculate confidence intervals. You also got the second question right. Very good. You know how to interpret the margin of error. It's very good. Question 3. Okay, so let's see what's going on here. We're just asked to interpret a confidence interval in the context of the problem. You chose answer B. So let's see why that's not right. Answer B says we can be 95% confident that the proportion of the sample who report no smoking incidents in the following year is between 17.4% and 24.8%. Okay, if you think about it, remember that the confidence interval is used to make a statement about the population value, not the sample value. So that's what's wrong with this one. We know everything we need to know about the sample, right? We know the sample value, and you know that we're not making a confidence interval for the sample proportion. We're making a confidence interval for the population parameter. So the correct choice would be D, since that says we can be 95% confident that the proportion of all nicotine patch users, that's the population, see, who would report no smoking incidents in the following years between those two numbers. So I think that would, I hope my explanation clears that one up for you. Okay, let's see, and you can see the feedback here. The nice thing about this video is you can pause it whenever you want. Number 4, you did correctly. You knew to check the normality requirements. Very good. Number 5, you also got correctly. You know that increasing the sample size will make the smaller margin of error, so you picked the biggest number there. Good. Number 6, let's see, what's the issue here? We're asked, what's the population? Okay, so let's see. We did an interactive poll on the front page of the CNN website in October and asked the readers if they would consider voting for Herman Cain. So the problem is that this is a voluntary response sample, right? It's an interactive poll on the front page of the CNN website. So you go to the website and you see the poll and you decide for yourself whether or not you're going to participate. So the sample's not random. Therefore, any of this other stuff down here about confidence intervals, it's all BS. We can't do, well, we can do it, but we can't apply the results to any population because, answer C, this was a voluntary response sample. So watch out for that kind of question. Make sure that you not only check normality requirements, but look at the sample and make sure that you have a nice random sample so you can apply to your population. Question 7, you did correctly. So I think you're good at figuring out what the alternative hypothesis is. Let's see. Number 8, very good. You were not distracted by the ones that had to do with means. You see, we wanted to know which one's about a population proportion. B is about a mean. C is about 2 different populations, males and females. And D, if you read through it, is first of all, it's about means, and secondly, it's about 2 populations. So D is wrong on 2 counts, so good job. Number 9, okay. All right, well, at least you didn't pick B answer. All right, let's see what's wrong with all of these answers. First of all, let me, like that. I think you can see it all. Okay, we did a study, determine whether a majority of college students plan to vote. Okay, majority means that you're going to eliminate answer D because majority is about proportion, so it's not answer D. And let's see what else. We found that 55% of the people in the survey plan to vote. So that's a statistics, and you wouldn't pick C because C has the 55%, the 0.55, and that's not the p-value. That's or p as in population value. That's the p-hat value, so it's not answer C. So now it's either A or B, and when you see why it's not A, you're going to be very upset. We wanted to know if the majority plan to vote. The majority means that you have to have more than 50%. So clearly the answer should be B, because that's where the alternative hypothesis has greater than. This one is just We don't know whether it's the majority or not. We just know that it's not 50%. You get the idea? We want to know if a majority votes, and so we want to test the alternative hypothesis that the majority voted for in the next presidential election. So that's why B is the correct answer. You can read their feedback. Probably explains it better than I do. Okay, here's question 10. All right, so for question 10, I know the issue here because I've already spoken about this one a couple of times. So remember that we have to check the normality requirements, and that means we need to know the expected number of successes and failures. So this problem has to do with the attendance rate. So the attendance rate for the school is 95%. That's what they think the population value is. And they're doing a little survey, and they're choosing 120 students, and they're seeing on that day 12.5% of the students missed school. Well, that's not the same as the attendance rate. That's the non-attendance rate. So that number goes with the 120, but that's a p-hat number. It's actually 1 minus p-hat. But anyway, I'm sorry, it's not even that. Just forget what I said. Anyway, that's the number, the percent who missed school. What we really need to do is calculate the expected number of successes and the expected number of failures. We get that by using the population parameter, 95%, and we see if the true value, because this is a hypothesis test, so assuming that this is the true value, then how many do we expect to be in attendance? You need 95% of 120. Well, 95% of 120 is clearly bigger than 10 because 95% is almost all. In fact, it's all but 5%. That 5% is the expected number of failures. 5% of 120, unfortunately, is only 6, I think. 10% is 12, so 5% is 6. 6 isn't enough failures. So the reason that we can't conduct a hypothesis test is because there aren't the correct number of failures. We don't have the right number. You use that 12.5% number, which has nothing to do with figuring out the expected number of failures. This is the these numbers are the actual numbers of successes and failures. Remember, if we have the p-value, so we're doing a hypothesis test, so we assume that I said p-value, I should not say that. I should say population value. We have the population value and we're assuming that it's true. Remember, when we conduct a hypothesis test, we assume that HO, the population parameter value, is equal to that number. So we know p is 0.95. So we calculate p times n and 1 minus p times n. We don't use the p-hat, we use the p. So I think the correct answer is C. Yes, the correct answer is C. I hope that made sense to you. Question 11, let's see, what is the test statistic? So here, to calculate the test statistic, let's see, I'll get my little calculator. Where is my calculator? I have to move this out of the way. Hang on a second, I'll get there. Here's my calculator. All right. Hello, calculator. Okay, so we did a Gallup survey in July. We found 20% of Americans favor reducing the U.S. budget deficit by spending cuts only, no tax increases. So that's a proportion. 20% favor reducing the deficit by spending cuts. Economics professor believes that fewer college students would favor deficit reduction through spending cuts only. And the professor surveys 500 college students and finds that 75 of them favor reducing the deficit using only spending cuts. What's the test statistic? Remember, the test statistic is p-hat minus p divided by sigma for p-hat. So the first thing we have to do is calculate sigma for p-hat. And to do that, we need to calculate a square root. So the way this calculator works is first you put the number in and then you press the square root button. So the number I need to put in is p-hat times 1 minus p-hat divided by n, which is 500. Okay, now p-hat is 75 out of 500, so I'm going to do 75 divided by 500. So p-hat is 0.15, 15%. So that's p-hat. 1 minus p-hat is going to be 85%. So I have to multiply 15% times 85%, or 0.85, and divide that by n, which is 500, and then press equals. Because of the way this calculator works, now I do square root symbol. Okay, that's my sigma value. Now I have to do p hat minus p and divide by this number. You're probably going to be rounding this number to 0.0159, and the 6 makes the 9 go up, and that makes it 0.016. When the 9 goes up, it becomes a 0, and the 5 becomes a 6. So 0.016 is my sigma. So p hat 0.15 minus p is 20%. I can do that in my head. 0.15 minus 20 is negative 0.5. So I want negative 0.5 divided by 0.016. Okay, negative 0.5. Is that right? 0.05. I'm sorry. 15% from 20% is 0.05. Divide that, and it's going to be negative. Divide that by 0.016. Negative 3.125. So the correct answer should be answer C, rounded to 2 decimal places. Whoops, correct answer is A, so I don't know what I did wrong here. 20 minus 15 is 0.05. The correct answer is A. So why did I'm not sure why I got it wrong there. I must have made some kind of error. I have 75 out of 500, right? 75 out of 500 is 0.15, and that's p hat times p divided by sigma, and then, no, it's p hat minus p divided by sigma. P hat minus p divided by sigma. 0.15 minus 0.2, and then divide that by the sigma, which I thought was 0.16. Okay, I can't figure out what I'm doing wrong here, so I'm going to pause the video and work it out and then see if I can fix it. Okay, I figured out what I was doing wrong. I forgot, when you calculate sigma for p hat, you use p, because we're doing a hypothesis test. So it's 0.2, whoops, not 22, 0.2 times 0.8 divided by 500, and then take the square root. So 0.178 or 0.018 is my sigma value, and I have to then do p hat minus p, which is again negative 0.05, and then divide by this, so 0.018. So I have 0.05 divided by 0.018. Okay, negative 2.78. I guess the closest answer they have is A, negative 2.80, so that's the one I'm going with. The difference is probably just due to rounding, but the mistake I was making before was using p hat when I calculated the sigma instead of using p when I calculated the sigma. So I forgot what I'm always reminding you guys about. In a hypothesis test, we assume that we know p is equal to the value given here. So we use p to calculate the standard error. That was my mistake. Okay, so let's keep going here. Number 12, you had to calculate the p-value. Instead of using the applet, just use your TI calculator. Let's see, we're doing a hypothesis test, and yes, they want the p-value, they gave you the significance level, and they gave you the test statistic. Here's what you did wrong, and I only know this because, again, I've done this a couple of times. This is a two-tail test. So the p-value is actually in two tails. So you probably calculated the p-value in the right tail by using the normal, let me get it here. Oh, I lost my calculator. I guess I must have closed it. Let me see if I still have it open here. Okay, here's my calculator. All right, so let's calculate that p-value. Okay, so if you use normal CDF, so we're going to go second dist, normal CDF, and it's a two-tailed test, so I'm going to go from my left bound, which is going to be 1.42, to infinity, which is 10 to the power 99.